curiosity, how many people know what oracles are in the context of Ethereum? Yeah, not bad, not bad. All right, so I'll leave you with Thomas, and enjoy.
Thanks. I'd advise you, my presentation will be much more boring than the previous one, and even much more technical. Let's start by talking about what people mean with oracles, because there are different meanings behind this term. Essentially, when we talk about smart contracts, we can see them as an evolution of what we had in Bitcoin with traditional transactions from address A to address B, and then multi-sig transactions, so transactions which, in order to be confirmed, needs a certain amount of signatures coming from different parties. Then we have smart contracts, which are just an evolution of this. So when we talk about smart contracts, we mean the enforcing of a certain logic at a network level, so that all the nodes in the network, such as Ethereum, look for a consensus on the new state of the contract, right? So we have the logic which is enforced by the network itself. But with this logic, we can do really amazing stuff. But in order to have really meaningful smart contracts and powerful smart contracts, at a point we need some data. We need a way to push data into these smart contracts, into this sandbox, or into this walled garden, which is the blockchain. So, as I said before, different people mean different stuff. So essentially, usually we refer to Bloomberg, for example. So banks refer to Bloomberg as an oracle, or Augur. Prediction markets like Augur, Gnosis are often referred to as oracles. Even Vitalik itself can be considered an oracle to some extent. And BTC Relay, for example, is another another oracle. Or even Reality Keys, which is a service which is signing data coming from a couple of data sources. So let's try to start from scratch and to give some definitions about what an oracle is in practice. So my definition is way different than the one we've just seen. So for me, an oracle is just the party which is pushing some data to the blockchain. So essentially, the oracle is the blockchain-aware party, which is in somehow pushing the data so putting his signature in the transaction to the blockchain. So let's try to make this clear and to say that Bloomberg, for example, today, with these definitions, in my opinion, is not an oracle. It's more a data source. So all the ones that we have seen before, all these can be considered data sources. So they are the parties providing the data. So when we think about Bloomberg, Bloomberg is just sending back to us some data, some financial data, while BTC Relay is just giving back to us the status of a given Bitcoin transaction, such as, is this transaction valid? Was this transaction included in a block in the Bitcoin blockchain? BTC Relay is the data source which is saying yes or no. And Augur, Gnosis are data sources as well, because they can provide at any time a number about how likely an event is to happen, right? So, and even Vitalik, of course. So, with these definitions, we have any of Wolfram Alpha, for example, Bitcoin blockchain, Bloomberg, Augur, or even the web, so APIs on the internet. All of these can be considered data sources. So this is the party which is providing the data. It's not blockchain aware at all. Then we have the oracle, which is the one pushing this data to the blockchain. And then we have the query. So the query is the actual formula that the data source can understand. So for example, with this definition, we can say that the Wolfram Alpha data source can understand a query like what's the temperature in London, or the Bitcoin blockchain data source can understand something like, was this given transaction ID included in one block in the last 12 hours? Or Augur can tell us something about, like, how likely is this event to happen next week? Things like that. So let's talk about an example. So, for example, if you want in Ethereum to move some funds from account A to account B under certain conditions, such as soon as Kraken BTC euro is below 300, then who is giving to us this data? So if you look at a Bitcoin approach, for example, we can just delegate the checking of the operation of the event to an external party which is capable of signing the transaction. So we can say, for example, okay, this is the transaction I want to approve when the event is verified, and the funds move from account A, which is a multi-sig address, which, for example, is controlled by a couple of keys, and we are moving these funds to another address. So in this case, we can say that the Oracle is signing the transaction, this specific transaction, with one of its keys as soon as the event happens, as soon as it's verified, and myself, I'm signing the transaction with one of my keys. So for example, I start by signing the transaction in advance, now, and then I have a partially signed transaction, right? So I have transaction which is signed by just one of the two keys. So in this case, I just ask to the Oracle, please put your signature as soon as the event is verified. So with the Bitcoin approach, which is this one, which is the delegation of the execution of the transaction to an Oracle, I'm putting complete trust in the Oracle itself, because I'm not sure about what the Oracle will do with the transaction. I'm not sure about how this condition will be verified. I just know that the Oracle claims that the transaction will be signed by him as soon as the event is verified. So the things that you can do on Bitcoin is just to increase the number of signatures and choose a number of oracles which can all understand the same language, and ask them to put their signature as soon as the event is verified to them. So for example, I can choose 10 oracles and say that the transaction is verified as soon as I have six signatures. And if at least six of these parties agree on the result, then they will be putting their signature, all of them. And if at least 6 of them agrees on the result, then the transaction will be approved. But in this way, we have no transparency. So we don't really know anything about how the condition was verified. We just know that these parties claimed that the event was verified. So what's interesting with Ethereum and smart contracts on Ethereum is that we can move this logic out of the single nodes and enforce the logic on our smart contract code. So this is a completely different approach, and this is where Oraclize comes in, which is essentially to keep the logic of the funds moving in the smart contract and just ask for data off-chain. So essentially, Oraclize is providing data to smart contracts, which means that if you have your Solidity code and you want to know what the Kraken ticker price is, you can just use some on-chain APIs and ask to our contract, which still lives in the Ethereum blockchain, which data source you want to use, which in this case could be Kraken, and then the formula, the query, which in this case can be, please tell us BTC air price, okay? Then the event itself, which is this one, will be just verified by your contract code. So the Oracle have no control on your funds, and you keep full control on the logic to move your funds. You just rely on the Oracle to get this data in. So essentially, with this way, which is very generic, you can use any data source, because the data source can be something like Wolfram Alpha or blockchain for the Bitcoin blockchain, or Amazon Mechanical Turk, for example, or IPFS, all of this stuff, or even URL, so any URL on the internet, any API, to request to another contract for this data. So the way Oraclize works is this. So essentially, you have your smart contract code, which is in total control of yours. So you define your logic, you define your Solidity code, and then we provide the APIs so that you can ask to the Oraclize engine, which lives off-chain, for for the data you need. So for example, let's say that you choose the Wolfram Alpha data source, and you ask Oraclize in your smart contract code, what's the temperature in London now? Oraclize does fetch this information from Wolfram Alpha, and along with the information, it uses a proof to prove its honesty. Why is this important? Essentially, the oracle becomes the escrow of the transaction, because he is in total control of which data will be provided to your smart contract. So if you're moving some funds, which depending, for example, on the ticker price of Kraken, the smart contract cannot get this data by itself, because you cannot open a socket via some Solidity code. You cannot open a socket in a decentralized way. So this is why you need to rely on an oracle in the first place. So by relying on Oraclize, essentially you are fetching this data, you're asking Oraclize to fetch this data for you, and to push this data back to the smart contract, along with a proof, which is the TLS notary proof, which is showing that it didn't alter the data coming from the third-party data source. Because of course, you cannot put trust in Oraclize, since Oraclize could be altering this data to gain some extra profit. So this is some example code, which is showing how simple the integration I just talked about is. So essentially, our API is just some Solidity code, and this is a price ticker. So it's a very simple contract, which is just here at line 23. He's using Oraclize query function to ask Oraclize to fetch this query, this formula, this data, out of the URL data source. So essentially this is saying, look, I live in a sandbox, I cannot get this information by myself. Oraclize, please send me back the result for this query. And Oraclize is listening for events coming from the blockchain, is fetching this information along with the honesty proof, the TLS notary honesty proof, and is sending back to the contract both the result that you asked for and the honesty proof. So your contract can then do whatever it wants with the data it just received. So essentially, how do we ensure that Oraclize is behaving honestly? How can we be sure that Oraclize didn't send back to us some altered proofs? So essentially there are two ways, and this is working today, and this is on our website, which is a monitoring of the service honesty off-chain, which means that you have a network monitor which is executing client-side code, which can all be verified independently. So even if our website is offline or things like that, just by connecting to the Ethereum node, even your local one, and IPFS, you can check all the proofs that were sent along the responses coming from Oraclize. So for example, by default, this tool does load the last 12 hours of blocks. So this means that all these pieces, all these ones are responses sent from Oraclize back to the network. And all these ones contain a proof that was verified by this client-side code. So it's quite technical how the verification works. If you have some questions, I can ask them later. But essentially, the TLS notary proof is a modification of TLS, which is giving a proof showing that the data coming from a given server at a specific time wasn't altered. So the amount of trust you have to put in this is not zero. You still have to trust Amazon Web Service specifically, because there are some APIs that are being used to ensure that one of the pieces needed to run TLS Notary is behaving honestly. This is why Oraclize is not trustless, it's provably honest, which means that we prove that we are behaving honestly, but we cannot really say anything about Amazon. So Amazon is still playing an important role here, because if Amazon Web Service is altering the API response, then potentially this response could be altered in principle. So let's say that this is a compromise essentially, which is as long as the external service, the data provider, is not sending the data directly on the blockchain, then how do we get this data in? The way to get the data in is to use an approach like this, which is providing a proof showing that even if the data source didn't put the information in the blockchain by itself, we can still push this data in with a third party, which is the Oracle, which is proving it's being honest, essentially. So to verify the TLS Notary proof on chain, we need to fork TLS Notary, and this is something that we are doing. So one of the main changes, for example, that we are doing is to change one of the signature in the process from RSA to ECDSA, so that it's easily verifiable on chain. And from our early measurements, I can say that this will not cost a lot. So we are in the order of 200K of gas. So it's really not a lot to verify the honesty proof. And this is useful to verify on-chain that the data that was received by the contract was not altered. Because one thing is to say, we can verify at any time the honesty of the Oracle by monitoring the blockchain off-chain. But this still means that if one transaction is being tampered, then some smart contracts will behave in the wrong way. And this is something you don't really want. So this approach will be much more powerful, because smart contracts could verify by themselves that the data is actually legit, and could refuse to use this data if the data and the proof does not match with the data you got. So other features that we are implementing are encrypted queries, because for example, if you want to use some APIs on the internet and get some information out from some private APIs, for example, you don't really want to disclose to the whole network your credentials. So one approach could be just to encrypt the query so that just the Oracle can understand this. But in this way, you still have, you have to put some trust in the Oracle. So we are adding new data sources. So for example, the Amazon Mechanical Turk one that I talked before is not available yet. We are still doing some tests to get a better consensus, because essentially the way it works is you can ask pretty much anything, and your request is sent to a certain number of agents, of human agents, and then there is an algorithm that we made which is looking for a consensus in the answer. So for example, if you are asking for a random number, the algorithm will never find a consensus. But if you are asking for the temperature in London, I mean, there is a good chance that you will get a consensus out of it. Other than this, we are integrating Oraclize as a plugin for EtherCamp IDE, so that you can easily test the integration with the service without having to test it on-chain on the model testnet or on the mainnet. Then the on-chain TLS Notary proof verification, as I said, and an HTTP API, which lets, for example, fetch the TLS Notary proof with no need of interfacing with the blockchain, which in some cases is something you want. And then a different kind of proof, because as I said, the proof is not zero, so you still have to put some trust in Amazon Web Service. And the only way to to lower the amount of trust, since you cannot remove a trust line with this compromise, is to provide a different kind of proof. So for example, with Intel SGX proofs, you can get pretty much the same security of the TLS notary proofs, but you are trusting a different party, which is Intel. So in this case, you can, for example, ask Oraclize to fetch the same data with 2 different proofs. So if both proofs does match, it means that both Intel and Amazon were lying, which is not that likely. So to talk about some use cases which are based on oracles, so which are based on data that we made, we have this Insurance, which was the winning project at the FinTech Week last year, which is essentially an automated auto-claiming insurance for flight delays, which means essentially that the insurance is paying out in 100% of the cases, which is something that the insurance mostly don't really want, since this is what they're basing their profit on. But this is a completely different approach. In fact, you don't even need the insurance company to have any role in this. So even the funds of the insurance products it's completely peer-to-peer. So any user can contribute to the system, and it's an investment which is pretty interesting because the code of the smart contract is open source, so you can verify by yourself that the on-chain version does match with the source code. And you can set, for example, the price of the insurance to be 5% or 2% higher than the probability of a given flight to be late. So in this case, in the long term, we are quite sure that a smart contract like this does have a profit. So another use case that we made, which is coming from a community request, was this YouTube contract, which is essentially saying, okay, let's say that a YouTuber wants to publish a video, and in the video some sponsors are advertised. So there is some advertisement for these sponsors. So these sponsors want to pay the YouTuber, but they don't really trust the YouTuber because they are not sure that the video will be as successful as they expect. So it's not easy to find the fair price, let's say. So one way could be to use a contract like this, which essentially is acting as an escrow, an automated escrow. So essentially the YouTuber can link to a smart contract instance a given YouTube video, such as this one, and can set an expiry date, such as that one, and a threshold for the number of views that you want to reach with the video. Then the sponsors can pay not directly to the YouTuber, but to the smart contract address. And then the smart contract can automatically check via Oraclize or another Oracle system for the number of views that the video got at a given time. So in our example, essentially, if the video didn't reach the goal, then 25% of the funds were sent back to the to the sponsors. And in the other case, the full amount was sent to the YouTuber. So this means that as a sponsor, you are sure that you are paying a fair amount because you are getting 25% refund if the video is not as successful as expected. While on the YouTuber side, you are 100% sure that the sponsor will pay you even if the video is not as successful as expected. So you can have a dynamic pricing, which is, so this is a very easy example, but the complexity can be any, so you can set even a much more complex algorithm for the pricing. Another project that we didn't release yet, we are releasing it in the next few days, is a bounty contract for stock exchange, which means that essentially you can set a bounty for a given answer on stock exchange, and if after a given period of time there is a successful answer, so an answer which is marked as correct, then the smart contract automatically tries to understand what the Ethereum address of the person, the author of the response was, and sends the full amount of the bounty to the one who gave the answer. So this means that you are trusting Stack Exchange, of course, because it's using Stack Exchange API. Even the other example, the YouTube one, was putting full trust in YouTube, but this is the only trusted party, and you are trusting it anyway, because for a YouTube video, YouTube could alter the views of the video at any time. So you're not increasing the trust needed, you're not opening any new trust lines, you're just delegating to an Ethereum smart contract, which is automated in this case, the execution of some contractual clauses, such as these ones. So on our GitHub page, you can find some code samples. There are different code samples with different difficulty levels. So there are some which are based on the fuel price, some others which are showing the integration with Shapeshift, for example, and things like that. And at docs.oraclize.it you can find the documentation. Then there is an IDE at dev.oraclize.it, and this is our Twitter handle. Thank you.
This should be a working mic. Does that work? Yeah, it kind of works. Anybody got questions? And then we can pass the other mic around. The working mic. Anyone? Pretty shy crowd tonight. There you go. There's one question from John. Let me get the mic to you, John.
Hi. You mentioned you were working on the Mechanical Turk interface, and it wasn't quite ready because you were working on some consensus code to interface between Mechanical Turk and what you're putting on the blockchain. Would it be possible also to interface directly into Mechanical Turk without your consensus code, so you can do your own consensus code in blockchain?
This is an interesting question, but it all comes down to the gas cost, because if you're interfacing to Mechanical Turk, you probably don't want to trust a single agent. So you probably want to ask to 10 agents and then try to find the consensus by yourself. But the problem is that all these agents potentially can give you back an answer which the length is different and is costing you a different gas price. So it's going to be much more complex. So in theory, it's definitely possible, but I don't see it being used in practice for this reason.
There's some, with some Mechanical Turk problems, the consensus algorithm can be quite domain specific. And so there's some
yes, I
using.
agree. So we essentially the algorithm that we found working for most cases for sure doesn't work, for example, for consensus on numeric values. So if you're looking, for example, at the temperature, for example, and it doesn't check the variance of the results or things like that. So the consensus is strictly on strings in this case. So for example, it's useful if the result is yes or no. Or yeah, for numbers it doesn't really work well. So for numbers it could make sense, the approach that you suggest. But it will be very expensive, I guess, on the smart contract side.
Thanks. Quick question: do you see any interest from traditional data providers like Reuters or Bloomberg to put data directly onto the onto the Ethereum blockchain?
So I think that Bloomberg will start at some point to push this data directly to the blockchain, because for sure there is a lot of demand. But the problem is that data sources can be pretty much anything. So think about all the websites that you might want to get some data from. All of them will need to integrate with the blockchain, to understand the blockchain, and to have a reliable service interfacing with the blockchain, other than finding a common standard to push this data to the blockchain. And I don't see this happening for most cases. So I think that Bloomberg is quite different, because essentially it's together with Reuters is one of, I think it's covering most of the market. So it's quite different depending on the data source that we are talking about. But I don't see them finding a standard soon. The point, as I said before, the Oraclize is a compromise, which means that today you can already get some valuable data with a proof which is 99% secure. So unless you have the data source putting some signature, some extra signature, or pushing the data directly to the blockchain, you will never reach 100%. And even in this case, you still have some trust involved, which is the trust of the data source. So.
Yeah, anyone else?
I can shout.
Yeah.
The back, anyone at the back? Yeah, all right, I'll give you the mic.
So how many confirmations does a typical query take?
Essentially, we are just looking for one confirmation, even if this is dangerous, because we have a way, let me go back with the slides to the code. Essentially, each query is identified by an ID, a unique ID, and this ID depends on an internal nonce, which, no wait, what was the code? Yeah. So my ID is an ID which is identifying the given query, and you always have the same ID for the contract, which means that you cannot have duplicate queries, for example, because our engine is detecting it on his side. So I think it's a pretty good compromise. And waiting for, I think it could be interesting for some particular use cases to let the number of confirmation be chosen by the contract, by the calling contract. But for at least the projects that are being based on Oraclize by the community, etc., in many cases are asking us to get really a high number of data in, so they are not willing to wait for 5 confirmation or things like that, because, for example, they want one data, one transaction back every minute, or things like that, and somebody is asking for one every block. So,
Thank you.
Anyone else? No? No, yeah, there's one over there.
So, are you worried about the blockchain getting too big because you have so many smart contracts?
the good thing with Ethereum is that there is nothing like fixed block size. So
The entire blockchain, basically.
Hmm?
The entire blockchain.
What's
It's 8 gigabytes now.
Yes, but I think that, for example, with sharding, we'll be lowering this issue a little bit, so that you can just consider the data that are meaningful to you in your shard. So I'm not that worried about this, because I see sharding being one possible solution.
When is sharding gonna be live?
I have no idea. hopefully next year.
And what's your opinion about proof of stake versus?
Not convincing yet.
All right, any other questions? Not relating to proof of stake? Yeah, no, all good? All right, thank you very much, guys. Not sure if we have any plans past this. Maybe Vlad can guide us towards a local pub, or maybe Chris, if you guys want to do something afterwards. But I was thinking first we do the little shoutouts, right?
Yeah, that sounds good. And also, we would need to get out of here in roughly half an hour, so we don't have that much space, that much time left.
Okay, well, fair enough. Anyone wants to do a little quick appraisal of their project, just like the gentleman did earlier? You can? Yeah. I thought you might want to.
Hi everyone, I just basically want to announce a couple of events I'm probably taking a part in and organizing. One going to take place in Berlin in the end of April, and a couple of. Then the next one going to be in Madrid during the Nesta event, and one in London as well later on. And everyone who's like a bit of a doomsday prophet is welcome. And basically there are enough people in transparency and scalability kitchen, and we're interested in security and privacy stuff. So anyone who's interested, talk to me or tweet at me. Talk to me first and find out my Twitter account. Yeah, that's it. Thanks.
All right, thank you. So Doomsday Prophets, we know where to go. Anyone else? No? All right. Well, thank you very much for coming tonight. We have another one next month for sure. Probably same time, same place, around the same date. That's about it. Thank you very much. Have a good night.